And next number is x plus 1. Next is x
plus
plus
2.
2, x plus 3, x plus 4, x plus 5, and this sum x plus 6. Okay, these are some conjugative numbers. If we want to check whether they are composite or not, what we can do? Actually, a number is composite if it is divisible by other than 1 and itself, like 2, 3, 4, some other number. Okay, you know 2 divides 2. 2 divides 2. Okay, can you tell me when this number is divisible by 2? What is the possible value of x so that this x plus 2 is going to be divisible by 2? Any
X
answer?
equals to
2n.
2n.
X
What is
equals
the
to
value of
2n.
x?
2n.
Multiple of 2.
x बोलो मैं लिख लेता हूँ बोलो एक बार
2n.
2n.
2n. Okay, other?
Even number, sir.
Okay, all the even numbers are going to be divisible, you want to say, huh? Okay. And notice, if x is equal to 2n, x is equal to 2n, then x plus 2 is what? 2n plus 2. This is
Yes,
also
sir.
divisible by 2.
Yes, sir.
That means if 2 divide this x, then definitely x plus 2 is a composite number. Yes or no?
Yes, sir.
Okay. The same situation you think when x plus 3 is going to be a composite number. If 3 divide x, yes or no?
Yes, sir.
If 3 divide x, then definitely x plus 3 is a composite number. Same case in x plus 4. If 4 divide x, then this is also a composite number. If 5 divide x, this is also a composite number. And if 6 divide x, this is also a composite number. Okay, but we want such a number x such that all of these property together satisfy, because we want all of them are to be composite. Okay, now you check, this is composite if 2 divide x, this is composite if 3 divide x. What is the condition on x such that both of them are to be composite number?
6 divided.
Divisible by 6.
6 divide x, that means you want to say that is x we choose such a number, 2 also divide x and 3 also divide x. If we want all of them to be composite number, then condition is that we have to find such a x such that 2 also divide x, 3 also divide x, 4 also divide x, 5 also divide x, and 6 also divide x. Can you tell me any number x such that 2, 3, 4, 5, and 6 all of them are going to
6
be
factorial.
60.
6 factorial. One answer is this. Another answer?
LCM
60n form.
What?
Any number times 6 factorial. It's basically.
Okay, any number times 6 factorial. Some other answer?
60.
Less than 6 factorial is any number. Can x take value some less than 6 factorial? Think
60n type.
what you are saying.
60n.
16?
60.
Okay, you are saying 60. Okay, 60 is the number. 2 also divide, 3 also divide, 4 also divide, 5 also divide, and 6 also divide. Any other number? Actually, how you are choosing this x, that I want to know basically. That is 6 factorial is a very easy number and comes in our mind very easily. That takes all the multiply of this number. That number is definitely divisible by 2, 3, 4, 5, and 6. And 60 is also a number. Also, you can take x to be equal to LCM of this 2, 3 up to 6. If you take LCM of these numbers 2, 3, and 6, then also you can see that all the number divide this number x. Any doubt in this x?
No, sir.
No, sir.
Have you realized that how this number, conjugative number, are to be coming like? you have to find a such a x. If you want to collect 5 composite number, then you need LCM of these number 2, 3 up to 6. That x and then adding 2, 3, 4, 5 and 6. You will be getting 5 composite number, conjugative composite number. Okay. I hope you realize the condition that how this sex. Maybe someone have see the answer. This answer is also correct. 6 factorial plus 2, 6 factorial plus 3, 6 factorial plus 4, and 6 factorial plus 5, and 6 factorial plus 6. This is the number which is divisible by, all of these are composite number and conjugative composite number. Am I right or not? Up to this point, clear or not?
Yes, sir.
Okay, from here actually you can realize that if you require to construct instead of 6 factorial, you can take also LCM of this number also 2, 3 and up to 6. I think that will be 6 into 2, 12,
60.
60, है ना?
Yes, sir. Yes, sir.
60 also work here. Okay, whatever you want, you can take it. Now, can you construct now 10 conjugative numbers, composite number? Can anyone tell me what is the answer of 10 conjugative composite numbers? Any answer using these two?
There would be 10 factorial plus 2 plus 3 plus 4.
What factorial? 10. We want 10 10. So, what? 10 factorial plus 2 up to 10 factorial plus 10. This is your answer or something else?
Yes, sir.
You can see how many these number are. Starting from adding 2, going up to 10. How many these number are? 9. That means you have to realize if you want to construct 10, then you have to take here 11 factorial. And then up to go 11 factorial plus 11. Understand or not? That means if you want to construct n conjugative composite number, you have to start from n plus 1 factorial. N plus 1 factorial.
Sir,
Yes.
sir, 10 factorial is also a composite number.
Yes, okay, you are starting from there, then it's work. If you start from 10 factorial, but is it, they are conjugative or not? 10 factorial plus 10 factorial plus 2.
Not
They are not
composite.
conjugative, na? There is gap of 2 numbers.
Yes, sir.
Yes, sir. Understand.
Yes, you have to start from 11. That is the trick actually that you will never going to be mistake actually. There may be some other process or number are exist which can be found easily, but these are definitely going to help you up to at any number. Starting from n plus 1 factorial plus 1, plus 2. And why the reason we are starting from 2 is that only prime number are starting from 2. Then n plus 1 factorial plus 3 and up to n plus 1 factorial plus n plus 1. These are the n conjugative composite number. It's clear now? Okay, read the question
Yes,
number
sir.
3. Prove that set of prime number is an infinite set. Okay, the main motive of this question is here only that if someone asks from you is that construct 100 conjugative prime composite number, then how can you construct? Okay, this is the questions, give answer how to find. Okay, now go to question number 3. Prove that set of prime number is infinite number. Set of prime number is an infinite set. Anyone have done this question or not?
Yes, sir.
Okay, by which method you have done this question?
By contradiction.
that using that you are constructing that Euclid method or something else?
I don't know exact name, but
Okay.
I took n. Let's say there are n prime numbers, and then I
Uh,
took product of all the prime numbers, means p1, p2, p3 up to n, and then I just added one to that. Then
yes, yes, it's correct. The same proof. There are some other proof also, but if you know that proof, that is very good. Okay. Okay. One has done this question. Can anyone have idea using second question? Can we done this question number 3? Second question is saying that whatever n you give me, we can construct that number of conjugative composite number. This means what? If you want to find out some prime number p, then there is length is going to be very large between two prime number actually, है ना? You can construct 100 composite, then 1000, and then so on. This question number second is saying basically there are a large gap between two prime number. But let's try to prove this question number 3. Let S be the set of all prime numbers starting from this 2, 3. It should be a finite. Okay, this S should be a finite. I am taking all the collection of these prime numbers and suppose it is a finite. That means there exists some largest prime number p. Okay, that means there exists some largest prime number p. But our claim is this cannot be happen. Actually, it should be infinite. Then, as someone has already suggested that how we can approach that question, let us define some x. X to be equal to 2 into 3 up to dot 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 p. Okay. Now define a new number x plus 1. Okay, define a new number x plus 1. If I am prove that this is a prime number, okay, there are two possibilities that x plus 1 is either a prime number or composite number. It's clear or not up to this point? Our aim is to prove that this set must be an infinite set. Let us possible that it should be a finite. Then there exists some largest prime number p. We define x by taking the product of all these primes, then defining a new number x plus 1. Okay, now x plus 1 have only two possibilities. Either it should be prime or it should be composite. Let us suppose it should be a prime number. Case 1. If we suppose case 1, let x plus 1 is prime. Then you check that this x plus 1 is going to be greater than this p. But according to our assumption, p be the largest prime number. That means, which is not possible actually, x should be a prime number, which is a contradiction to the fact that our assumptions. Again, if we suppose it should be a composite number, then how to fail this condition? Can x plus 1 be a composite number? Composite means what? There is some prime number which divide x plus 1. Okay, there is some prime number x which divide this x plus 1. Can 2 divide this prime number x plus 1? Is it possible that 2 divide x plus 1? Any answer?
yes, sir, it's possible.
How it's possible? What you take x?
If
Okay,
x
you are saying
itself
it's
is
possible. Let's try 2 divide x according to you. This is the notation actually. If 2 divide x, okay. Sorry, x plus 1. Huh? It is. I want to know that whether this x plus 1 is divisible by 2 or not. Let us suppose 2 divide x plus 1. Okay. By seeing this number, is 2 divide x also? 2 divide x also, because we define x like that, this 2 into 3 up to p. Am I right or not up to this point? Now, if 2 divide x plus 1 and 2 divide x, if a number dividing two numbers, then that number must be divided their difference also, their sum also. Okay, this line is clear or not? I am using here a property that if any number divide two different number, then definitely it's going to be divide their difference also. And what is their difference? X plus 1 minus x. This will imply 2 divides 1. Okay, which is a contradiction because 2 does not divide 9. That means that 2 cannot divide x plus 1. It's clear or not? 2 cannot divide x plus 1.
Please explain one more time, sir.
Okay, I am supposing we want to show that 2 cannot divide x plus 1. Let 2 divide x plus 1. मान लिया एक मिनट के लिए. Okay, then you know that 2 divide x also, because x to be nothing but product of 2, 3 up to p, all primes number. Up to this point it's clear or not?
Yes, sir.
Okay, this first one we are assuming that let divide this one, and this is already correct, 2 divide x. Then I am saying there is a property that if a divide b and a divide c, then a also divide b minus c, also b plus c. Okay, I am using this property. If a divide b, a divide c, then a is also divide their difference and sum. That means what? By taking value of b is x plus 1 and value of c is x, this will imply 2 divide 1, which is not possible. Now understand or not?
We can also take any prime instead of 2.
Okay, instead of 2, if you take another prime number p, any of them, then also the same problem is coming, that p divides 1.
Yes, sir.
That means none of the prime number divide this x plus 1. Okay?
Yes, yes, sir.
Yes, sir.
If it is a composite number, there should exist now a prime number which divide this one. That means, but prime number are only these one in our hand. Now x plus 1 na to prime and neither composite number. That means what? Something is going to be wrong actually in our assumption, which is a
Yes, sir.
contradiction to our assumption, because every number is either prime or composite. Okay? That means this set must be an infinite set.
That.
It's clear or not?
Yes, sir.
Anyone have doubt in this question? It's a very
No, sir.
interesting question if you see. Huh?
No, sir.
Okay, question number 4. For question number 4, I am suggesting you have to know the definition of least upper bound and greatest lower bound.
Yes, sir.
Sir.
If that definition are clear, then you can do this question's proof very easily. What is the definition of a least upper bound? Anyone can tell me what is the definition of this least upper bound?
So the greatest number in the set
Yes.
A number which is greater than or equal to the greatest number of the set.
Again, what you are saying?
A number which is greater than or equal to the larger number of the set. The biggest number of the set.
Okay. But if suppose this is the set 0, 1, then what is the larger element of this set? Interval 0, 1.
Sir, basically the lowest upper bound is a real number. मतलब all elements of the set
हाँ हिंदी
are
में बोल सकते हो जैसे भी आपको समझा सको बताओ.
sorry sir.
नहीं, you can talk in हिंदी also, अगर उसमें definition अच्छे से बोल पा रहे हो ना कोई दिक्कत नहीं.
हाँ ठीक है सर. सर मतलब लोएस्ट अपर बाउंड एक ऐसा एलिमेंट है, मतलब सारे सेट के जो भी एलिमेंट्स है वो उस एलिमेंट से कम होंगे या फिर इक्वल होगा, मतलब कोई एक एलिमेंट, मतलब जरूरी नहीं कि लोएस्ट अपर बाउंड कंटेन्ड हो सेट में.
Okay. You are saying that a number या तो वो इन सबसे बड़ा होगा या इनमें से किसी के इक्वल हो सकता है।
हाँ
एक्चुअली यू कैन से दैट इजीली suppose a set A, ठीक है, then a number U satisfying following two condition. First condition is U is upper bound. U is upper bound. What is the meaning of upper bound? That meaning is that all the x are going to be less than equal to U for each x belonging to the set what I have taken A. Okay, this is the definition of upper bound. If any number U belongs to suppose R, it's said to be upper bound if it is greater than or equal to all the number. This is the definition of upper bound, not a least upper bound. Okay, and second thing is if U dash is another lower bound, sorry, another upper bound, then U must be less than equal to U dash. Okay, actually least upper bound की यही दो properties हैं. It should be an upper bound and it is the lesser than all the other upper bound. It's clear or not?
Yes, sir.
And the same for greatest lower bound. First thing is it should be the lower bound, and the second thing is it should be greater from all the other lower bound. Okay, now come to this question number 4. What it's saying, read this question. It's saying that any bounded above subset of R has a least upper bound. This is statement A, and statement B is any bounded below subset of R has a greatest lower bound. Both the statements are to be equivalent. Okay, how we can prove? The proof is very simple. If you suppose this statement A is true, you have to prove that, if you suppose A, then you have to prove B, and if you suppose B, then you have to prove A. Actually, both are very easy. One case I am trying to do. Which one you want from me? By supposing A or by supposing B?
By supposing A.
Okay. So let A be a bounded subset of R. This is our assumption. Now assumption is what? If we get any bounded above subset of R, then it should have a least upper bound. Okay, this is our assumption. Any bounded above subset of R has least upper bound in R. Okay, and we want to prove that any bounded below subset in R has a greatest lower bound in R. This is our aim. Okay, let us define some set S. This is true for any subset of A which is bounded above. Okay, let S be subset of R which is bounded below. Okay, S is a subset of R which is bounded below. What is the meaning of bounded below? Can anyone tell me?
It has
What is the
greatest
meaning of
lower
bounded
bound.
below?
It has greatest lower bound.
There exists a number for which all the numbers in the set are greater than equals to that number.
Yes, this second one it's correct. Okay, this will imply that there exists a number, say L. This will imply there exists a number L belonging to real number such that L is less than equal to X for each X belongs to the set S. Okay, I am not using anything, just use the definition of bounded below set. Okay, meaning is what? There exists a real number L belonging to R such that which is going to be lesser than or equal to all the numbers inside the set. Up to this point, any doubt?
No, sir.
Okay.
No, sir.
Let us define some new set. Okay, if this condition is true, so Then you can also see this one. This minus L is going to be greater than equal to minus X for each X belonging to the set S. Can I say this one?
Yes, sir.
Minus L is greater than equal to minus X, because if we multiply by minus, inequality change its sign. Okay, define a new set T. Okay, define a new set T. Element in T are how? Minus X, such that X belonging to S. Okay, elements in T are negative of the element of S. Okay, I am defining here minus X such that X belonging to S. Now you see that all the element in this are of the minus X form, and the element of the form minus X are less than equal to minus L. Using this thing, this minus X is going to be less than equal to minus L. This means what? If this means what? Minus L is the upper bound for the set T. Understand or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, this will imply minus L is the upper bound for which set? The new set we have defined T. Okay, minus L is the upper bound for set T. This means T is bounded above. This means T is bounded above set. Bounded above set. T is bounded above set. Till now we do not use our assumption. Okay, this up to this point we are just using definitions. Okay, using these things we got that T is a bounded above set. Okay, what is the meaning of a bounded above set? Now what our assumption is saying? Assumption is saying if A is bounded above subset of R, then it has a least upper bound. And now we find that T is bounded above set. That means what?
T has a least upper bound.
T has a least upper bound. Say, take some number which is least upper bound. Let us take U. Okay. Let U be the least upper bound. Okay. Let U be the least upper bound of set T. Okay. Now, what is the benefit of least upper bound? I have already told you, if U is least upper bound, then what are the conditions? It should be an upper bound, and any other upper bound is going to be greater than this number. Okay, I define this definition just starting the proof. Understand or not?
Yes, sir.
Yes, sir.
And you see that minus L is upper bound. Minus L is what? Upper bound. Okay, let's take one more time. If U is upper bound, then the first thing is U is upper bound. This means what? This line implies actually these two conditions. U is upper bound and some U dash is another upper bound. U dash is upper bound. Then U must be less than equal to U dash. Okay. This is the definition of this U. Up to this point is clear. Okay. Now U is upper bound. This means what? U is upper bound. This means what? It should be greater than equal to all the elements of the set T. It should be greater than equal to all the elements of set T. Okay.
Yes, sir.
This means what? U must be greater than equal to this T for each T belonging to the set this capital T. Understand or not? But this will imply how element in T are. This is same as saying this condition. This U must be greater than equal to minus X for each X belonging to S. Because the element in T are itself this form that of minus X for X belonging to S. This point is under clear or not? U is greater than equal to this minus X for each X belonging to S. Because element in T are of this form minus X. And U is an upper bound. That means U should be greater than equal to all the elements inside the set T. This
Yes,
point is clear.
Yes, sir. Okay.
Any doubt?
No, sir.
Okay. Then multiply by -1. This will imply minus u is going to be less than equal to x for each x belonging to S. Okay, minus u is less than equal to x for each x belonging to S. What it should means? Can anyone tell me what is the next line after that I can write from here?
Minus u is
Minus u
the
is the
lower
lower
bound.
bound. Minus u is the lower
S
bound.
for what set?
S.
T. S.
S.
S. This will
S.
imply
S.
minus u is lower bound for set
S.
S. Okay, minus u is a lower bound for set S. But actually we want to find least upper bound, sorry, greatest lower bound for the set S. If this is a lower bound, if am able to prove that it should be greater than any other lower bound, that means, for example, this L is any other lower bound. If I am able to show that this L is less than equal to minus u, then minus u is what? Only if I am able to
Greatest
show,
lower bound.
then minus u is greatest lower bound, and that things we want actually. This S set must have greatest lower bound. Okay, now up to now we prove that minus u is least upper bound, sorry, lower bound for the set S. Now we, up to this we use only this first property. The second property is remaining, that u S is an other upper bound, then u must be less than equal to u dash. And you see that where this minus L is upper bound for the set T. Minus L is the upper bound for the set T, and u is least upper bound. That means what? What is the relation between minus L and u? This is upper bound for set T. This is least upper bound for set T. I want to know this u and
Minus L
minus
greater
L.
than u.
The u less than equals to minus L.
U
Minus
is
is
less
greater
than
than
equal
u.
to, this is correct, na? U is
Yeah.
less than equal to u.
Yes.
Now just by multiplying both sides, what we get? Minus u is greater than equal to L. And this is we want actually. That means minus u is greater than all the other lower bound. That means minus u is greatest lower bound. It's clear or not?
Yes, sir.
Okay.
sir.
I think now you other part you can try just using the definition of bounded below and all those things. Okay. Question number 4 is done. Now question number 5. This is done, I think, in the class.
Yes,
Actually, okay, this is the one more thing I want to tell in question number 4. This is the statement like that any bounded above subset in R has a least upper bound in R. But you see that question number 5, the set S, which is bounded above in Q, but it should not have any least upper bound in Q. This is the thing actually question number 5 want to tell you. That means R has some special property. If it has a bounded above set, then it must have a least upper bound. But in case of Q, the property should not be true. And the name of that property is completeness property. Okay. Just now coming to the question number 6. Tell me how many one have done this question. What its meaning actually? So that rational number between any two distinct real number. That means if you take two distinct real number, there must exist a rational number. Anyone have tried or done this question?
No, sir. This is a doubt.
Okay.
Just a doubt.
It's an interesting question. Okay. Just if you try before, then it's going to be easy to understand for me. And this is my mail ID. In every week, I am going to take your this tutorial. So you can mail me if you have doubt in any other questions. Okay. What is our aim? We want that between any two real number, there is some rational number. Can anyone tell me which form of rational number are So how to represent a rational number?
P by Q form.
P by Q form.
Yeah. Q is not equal to.
P
And
and Q both are integers.
both are integer or say P is integer, Q is natural number, that is also
And
fine. Both can
and the
hold.
LCM
GCD is
LCM
1.
of both of PQ is 1.
Co-prime.
GCD is 1,
They must
I
be
guess.
co-prime.
You can say co-prime also. Okay, this is our aim actually, to show that between any two real number there exists some number of the form P by Q. Okay, how to approach this question? Do you know Archimedean property? Okay, suppose Archimedean property is saying what? If x and y are two positive number, x and y are two positive number, then there exists some natural number n such that nx is going to be greater than y. That means if you have two positive number, there definitely exists some natural number n. After multiplying by that number, one number is going to be greater than this another number. Okay, this is Archimedean property. We want to use this one. Okay, that's why I am recalling this one. Okay, and this property is true if x and y are positive number. So let x and y be any real number. Any real number. Okay. If their real number, one of them must be greater than, other one is less than. Okay, without loss of generality, let us assume x is going to be less than y. Okay, without loss of generality, let us assume x is going to be less than y. This means what? Y minus x must be greater than 0.
0.
Okay. It cannot be equal to 0 because if both the number are equal, then there, how to find in between them rational number. Okay. Now this is a number which is greater than 0. You know 1 is also greater than 0. That means y minus x and 1 are two positive real number. Then by Archimedean property, there exists a natural number n such that this n time x minus y must be greater than 1. Am I right or not? There must exist some natural number. Maybe it should be very large, 100, 1000, but definitely it's going to be exist someone that this n into x minus y is going to be greater than 1. It's clear up to this
Y
point?
minus X.
Sorry, y minus x. Yes, thank you. Y minus x. Okay, it's clear now. Okay, this means what? This means what? This ny minus nx is greater than 1. Okay, ny minus nx is greater than 1. You see that ny and nx are to another real number and their difference is going to be greater than 1. That means what? If this is a real number line, this is say nx and somewhere is ny, then in between length is going to be greater than 1. That means I can say that there must exist an integer between these two numbers. If
Yes, sir.
difference between both were greater than 1, then definitely there is some integer which is greater than, sorry, which lies in between them. It's clear or not?
Ji sir.
Yes, sir.
Okay, let it should be m. Nx is less than m and less than equal to ny. Ny or what? Let's write ny is greater na, huh? Okay, this should be less than ny. Nx is less than equal to m and less than ny. That means dividing both sides by m, because n is natural number, positive inequality doesn't change m by n less than equal to y. That means what? This m by n is any rational number. Sorry, here equality is not there. That means x is greater than m, less than m by n and less than y. You see how to find some number between these two numbers. It's clear or not? Any doubt?
No, sir.
No, sir.
That means you find between two real number one rational number. Can you find
Can you please repeat
infinite?
the part of M? I didn't get it.
Okay. I'm saying their difference is greater than 1. That means in between them there must be an integer. This part you got or not?
Yes, sir.
Okay. Nx is less than m and less than ny. In between number, meaning of this one, it should be greater than one number and less than another number. Then dividing both sides by n, you will got that x is less than m by n and less than y.
Okay, sir, I got
M
it.
by n is nothing but a rational number. Okay.
Okay, sir.
That means what you have done till now, you have to find a rational number between two real number. Can you find infinite many rational number between two real number?
Yes, sir.
How?
सर n की वैल्यू चेंज करते जाएंगे.
n की वैल्यू चेंज करते जाएंगे तो क्या गारंटी इसी में रहेगा? छोटा भी तो हो सकता है कि नहीं? या तो इतना छोटा हो जाएगा n x से लेफ्ट में चला जाए. देखो, this is nx, this is ny yours, or forget it, this is just x, this is your y. You have to find a rational number between these two. This is one rational number. It's clear or not?
Yes, sir.
Now you take these two, x and r. These are also two real number. Then can you find out some more rational number here? What that one says, take any two real number, then definitely there exists a rational number between them. Now you take x and r to be real number. R is real also, na?
Yes, sir. आर्किमिडियन प्रॉपर्टी दोबारा से लगा दो.
What?
So we have to use Archimedean property again.
Yes, again and again. That means no need to use again. You can say that you have to prove now between any two real number there must exist a rational number. By that method, there must exist some rational number R1. Then you can take these two. There also exist. You can these two, these two, these two. कितनी बार लेते रहो खत्म ही नहीं होंगे, है कि नहीं? That means there exist infinite many rational number. Okay? Correct or not?
Yes,
Yes,
sir.
sir.
That means this property of real numbers, rational number are called dense property. That they are dense in R. That means wherever you go in R, there you will find some rational number. Okay. There is nothing gap between rational number. Okay. Now, can you find some irrational number between two real number? Okay, let me explain just very quickly. This is suppose x and y are two real number. We want to find out actually infinite many irrational number between them also. But first target is to find one. If we find one, then repeating that process, we have infinite many. Okay, then you can see that x and y, then x by root 2 and y by root 2 are also real number. Okay. That means by this previous argument, there exists a rational number between them. Some are. Don't think that argument to be for x and y. That argument for any real number. Okay. X by root 2 is a real number. Y by root 2 is a real number. That means between them there must exist some r. R belonging to Q. This point you got or not? Any doubt in this point?
No, sir.
No, sir.
Please explain again, sir.
This point.
जी सर ये वाला हाँ
यही वाला
हाँ,
सर.
वो part.
You know x by root 2 is a real number.
Yes, sir.
Y by root 2 is a real number.
Yes sir.
Yes, sir.
And the previous argument is saying if you have two real number, there must in between them there is a rational number.
Yes, sir. Yes, sir. आ गया.
I am writing just that one. Okay. Now this will imply multiplying both sides by root 2. X is going to be less than r root 2 and less than y. This point is clear or not?
जी सर.
And r by root 2 is rational or irrational? R into root 2. R is a rational number multiplied with root 2. It's
Irrational
rational
number.
or irrational?
Irrational.
Irrational. Irrational.
Irrational. Then actually what you have done, you have to find a irrational number between any two real number, and then you can use again that method, taking these two numbers, there are infinite many. Okay, it's clear or not?
Yes, sir.
Okay, question number 7. I hope you have to done this question. Okay, can I skip this question? Otherwise it's not going to be complete. You have to just find infimum and supremum. Please try this question. Okay,
Yes.
if not going to be done, you can mail me, then I will maybe send some solution of this question. Okay,
So what's your mail ID?
Sir, your email ID.
Yes, sir.
I have write there. You can see this
Okay.
one. PhD 200114111@iiti.ac.in. Okay. Now read question number 8. What it's saying that supremum of S is alpha. Please mute your mic, otherwise voice is coming. Maybe you not using headphone. Eighth question you have done or not? Is saying that supremum of S is alpha. Then prove that to prove any epsilon greater than 0, for any epsilon greater than 0, there exists a number alpha naught belonging to the set S such that alpha is going to be less than this alpha naught. Okay, alpha is going to be less than alpha naught. This you want to show. Have anyone have idea that what we are doing actually in this question? We are saying that supremum of a some set is alpha, and we are saying that just subtract something. Okay, what I have to write here? Sorry, this is alpha minus epsilon. Alpha minus epsilon. We are saying if we subtract a little small number from the supremum of the set, supremum is nothing but least upper bound. That means if we subtract something from the supremum, then there must exist a number in the set S which is going to be greater than alpha naught. This meaning is nothing. Actually, we are saying that this alpha minus epsilon is not an upper bound. Clear or not? Any set is upper bound कब होता है? जब सारे एलिमेंट से बड़ा हो जाए. If this is not an upper bound, that means what? There must exist some element which is greater than this alpha minus epsilon. Actually, this we want to say, na? Just using that two property, that this is an upper bound and it's a least upper bound, that it should be less than any other upper bound. We can prove this argument also. Let me give you some hint. Let it possible. ऐसा मान लेते हैं there does not exist any alpha naught which is greater than alpha minus epsilon. If this is not possible, then what is the situation in our hand? This means all the x are less than equal to this alpha minus epsilon for this for x belonging to this set S. It's clear or not? If we cannot find any alpha naught which is greater than alpha minus epsilon, that means all the element inside S are less than equal to alpha minus epsilon. This means what? Alpha minus epsilon is what? Alpha minus epsilon is what?
Upper bound.
Upper bound. This is upper bound. But alpha is least upper bound. This means what? Alpha must be less than alpha minus epsilon, because this is least upper bound. Is it true that alpha is going to be less than alpha minus epsilon?
Contradiction.
Contradiction. That means there must exist an element in S naught which is going to be greater than this number. Actually, the main aim of this question is nothing but it's want to tell you if you subtract very less quantity from the supremum, then it's not going to be upper bound no more. Okay, just read question number 9.
हिंदी में एक बार समझा दीजिए सर, समझ में नहीं है.
ओके, एक्चुअली ये क्वेश्चन यही कहना चाह रहा है, इफ सुप्रीमम ऑफ सेट इज एन अल्फा, अगर उसमें से हम कुछ सब्ट्रैक्ट कर देते हैं ना, छोटी सी भी क्वांटिटी, तो वो फिर से अपर बाउंड नहीं रहेगा, यानी कि कोई ना कोई एलिमेंट उस सेट का मिल ही जाएगा कि अल्फा माइनस एप्सिलॉन से वो एलिमेंट बड़ा होगा. ये अपर बाउंड होगा तो क्या होना चाहिए, सारे एलिमेंट इससे छोटे होने चाहिए ना, बट क्योंकि अल्फा सुप्रीमम है, लिस्ट अपर बाउंड, तो ये कहना चाह रहा है कि उससे छोटा अपर बाउंड नहीं मिल सकता. दैट मीन्स अगर उससे छोटा हम लेंगे तो कोई ना कोई सेट में एलिमेंट होगा जो उससे बड़ा
हो जाएगा.
Okay, read question number 9. It's also a very good question. Okay, and for question number 8, there is one line in the last. Think about a similar statement for the greatest lower bound. Sorry, bounded below subset of R. That means this want to say, actually, let me write, if infimum of some set S is say beta. Okay, if infimum of some set S is beta, then any epsilon greater than 0, अगर हम कोई epsilon greater than 0 लेते हैं, there must exist some alpha naught belonging to the set S such that this beta plus epsilon is not a lower bound, because beta is the greatest lower bound. That means what? Beta plus epsilon cannot be lower bound. That means there exists a number which is going to be less than this number. That is the same as alpha naught. Okay, try to prove this statement also. Now read question number 9. Anyone have tried this question or not? Okay, just read very quickly. T is equal to x minus y modulus. All the elements in this set are x minus y modulus such that x, y belongs to the set S. And supremum of S is what? Capital M, and infimum of S is small m. That means, and it wants to know that what is the supremum of this set. That means if you have to given supremum of some set S, then taking the difference and modulus all the elements from the set S, then what is the supremum of this set T? We have to prove that the supremum of set T is nothing but this capital M minus small m. It's clear or not? This we want to show. Okay, supremum means what? Least upper
bound.
Okay, and least upper bound means we have two property. Which property?
It must be upper bound.
First, upper bound, and second,
it is less than equals to all other upper bound.
oh, less than equal to or other
Less than
upper
upper bound.
Yes, and one more. If you see the question number 8, the second condition can be replaced by this condition also. That means it should be an upper bound, and if we subtract from that epsilon, there should exist an element which is greater than that. Okay, it should be least all the upper bound means what? उससे छोटा upper bound नहीं मिलेगा, तो क्या होगा? अगर उसमें से कुछ घटा देंगे, तो that is not going to be more upper bound. The second condition can be replaced by this 8th question condition. Okay, now let's try to see. Now you see very easily how to say start. Okay, x and y are going to be less than equal to this capital set M. It's clear or not? And this means what? Well, just take what I take x is going to be less than equal to M. Now small m is less than equal to y. This means what? Multiplying both sides by minus. This means you got minus y is going to be less than equal to small minus m. Then add these two. Okay, I'm using just a property of upper bound, because if capital M is supremum, it should be greater than all the element. It's also an upper bound, na? And this is lower bound also. That means m is less than equal to y. This will imply minus y is less than equal to minus m. Up to this, it's clear or not?
जी सर.
Yes, sir.
Yes, sir.
Yes.
This means what? Now add these two inequality. That means x minus y is going to be less than equal to capital M minus M. And this is true for all x and y in S. You take any x and y, this condition is going to be true. Up to this point, it's clear or not?
Yes, sir.
Yes, sir.
Now you can see from here, if x and minus y के लिए ये condition सही है, and x and y can be anyone from the set S. That means this is also true for y minus x also, because x minus y can be anything na. All the element we are subtracting, it's just not a single element. I'm not saying like that if 2 minus 3 is less than some number, then 3 minus 2 is also less than some number. This may not be true, but actually these are collection of all the elements, subtraction of all the elements. Sometime x is greater than, sometime y is greater than, then all subtraction are going to be less than this number. That means y minus
sir.
x is also less than equal to m minus m. If a number is less than m and another is also, that means their modulus is also going to be less than that number. X minus y modulus is going to be less than equal to m minus m. And this means what? M minus m is upper bound for the set T. Till now we have to prove just this is an upper bound. Now another thing is required to be proved, it should be least upper bound. This point is clear or not?
Yes, sir.
Yes, sir.
Now how to prove that it should be a least upper bound? I am using question number 8. If I am able to prove that this m minus small m minus epsilon is not an upper bound, if I will able to prove that this m minus m, this is an upper bound. If I subtract epsilon from this, if this is not going to be upper bound, not an upper bound, then this is definitely going to be least upper bound, this m minus m. It's clear or not? Up to this point, it's clear or not?
Sir, repeat
Yes,
last
sir.
statement.
Anyone is saying something?
Sir, last statement repeat कीजिए.
It's this line is not clear.
No, sir, repeat it.
Okay. We want to prove that m minus m is least upper bound. Okay, least upper bound. We have to prove that m minus m is upper bound. If we prove that nothing less than this number is not an upper bound, अगर हम इससे छोटा कोई भी नंबर लेते हैं m minus m से, तो वो upper bound नहीं है. That means what? This is the least upper bound, ना?
Yes, sir.
Okay. Now, if we want to show this is not an upper bound, what it means? We have to find m minus epsilon is less than some number in this set, some of this form, x naught minus y naught. If I am able to prove this one, if I am able to find out some element in set this one for each epsilon greater than 0, then our job is done. If I am able to find out some number, it's clear or not?
Yes, sir.
Then how to find that number? That is the main thing actually. Okay, let's try to see. Now, this capital M is supremum for the set S. Then you see that m minus epsilon by 2 is not a supremum for the set S. That means there must exist an element x naught in S using the question number 8. This point is clear or not? Try to see.
Sir, why epsilon by 2?
Yes, why epsilon by 2? Actually, I want epsilon. I also using epsilon by 2 here because epsilon is any number, positive number. Epsilon by 2 is also a positive number.
Okay, sir. Okay.
That means m minus epsilon by 2 is going to be less than x naught belonging to S, because m is supremum for the set S. And similarly, small m is what? Greatest lower bound for the set S. If I add something into this, epsilon by 2, then this is not going to be a lower bound. That means there exists some element which is going to be less than this element, say y naught. Okay, using similar property of question number 8, second part, which we have not proved, but I am telling, this is clear or not? If small m is infimum, then if we add something, this is not going to be an lower bound. This
Yes,
condition
sir.
is clear or not?
Yes, sir.
Okay. Now just multiply
Yes,
by
sir.
minus m. Okay. Multiply this minus m. Then you got minus m minus epsilon by 2 is going to be less than minus y naught. Okay. Then add this one and that one. Then add this one and that one. This inequality minus m and this one. Then you got actually, if you add left hand side into left hand side, you will got m minus small m. This is minus epsilon by 2. This is minus epsilon by 2. This is minus epsilon. And this is going to be less than this x naught minus y naught. This point is clear or not? So this is the only reason why I am using here epsilon by 2. It's clear or not? Any doubt in this line?
Yes, sir. Clear.
I'm just adding this inequality and that inequality, this minus m minus epsilon. I'm not doing anything, just using the definition of this greatest lower bound and least upper bound. If you realize this definition, fill this definition, you can write very easily this thing. But we want, what is our aim actually? Not x naught minus y naught. We want some modulus type because element in the set T are of this form. And you can see that x minus y naught is always less than equal to its modulus. Is correct or not? X naught minus y naught modulus x minus y naught is always going to be less than this x naught minus y naught. It's clear or not?
Yes, sir.
सर आपने जो
Yes,
x
sir.
नॉट और y
Yes, yes, हाँ बोलो, कोई बोल रहा था x naught y naught के बारे में? बोलो बोलो, क्वेश्चन पूछो तभी तो समझ में आएगा जल्दी. ठीक है, so that means m minus epsilon is less than equal to this element, and this is the element of set T. That means meaning of this line is that this m minus small m minus epsilon is not an upper bound.
डिफाइन किया है वो सेट s के लिए किया है ना.
हाँ हाँ बोल, which one? No, this is for
Sir,
this
I
is
guess
very much
connection problem था. इसीलिए you could not hear the question he said.
okay, okay, now tell me. अभी भी आवाज नहीं आ रहा है तुम्हारा, कनेक्शन वीक है क्या?
हेलो सर, सर कनेक्शन गया था मेरा.
अच्छा बताओ फिर, जल्दी बताओ.
सर जो आपने x नॉट और y नॉट लिया है, मतलब स्मॉल m प्लस
हाँ.
epsilon by 2 is greater than y नॉट. So there is also a possibility that y नॉट is greater than small m plus epsilon by 2. After all, y नॉट belongs to s, then there is always a possibility.
You want to say here y naught also may become?
No sir, in the left side, m
हाँ
plus epsilon by 2 is greater than y naught.
हाँ.
Then there is also a possibility that there is less than or equal to sign.
No, less than is not as there is possibility, but I am saying one y naught definitely exists such that this greater than sign is coming. Not all, but one element definitely we can get always. Because
Yes,
if we
sir.
do not get this y naught, that means all the elements are greater than this number. That means this is a lower bound. Then how m can be greatest lower bound? This is greater than m, na?
Okay, okay sir, I got that.
I'm not writing very properly. This is, there exists a y naught. Definitely you are saying very correctly. There are number in S which are going to be of this form, less than form. Okay, but one element definitely exists. Okay.
There exists at least one element. Why not?
There exists at least one element. This is the statement of question 8. Na, there exists some element. Yeah, at least one you can say. Okay. That means this is a least upper bound. Okay. Actually, now 3 questions are to be left. These are regarding monotonically increasing and bounded above.
Excuse me, sir.
Yes.
सर तो कंक्लूजन क्या है, मतलब आपने लास्ट स्टेटमेंट लिखा उसके बाद?
Yes. Very good. इस स्टेटमेंट का कंक्लूजन ये है, दिस m minus small m minus epsilon is less than what? X minus y naught into modulus. That means we have to find a number in set T which is greater than this number, m minus epsilon. That conclusion is that if we subtract any number from this number, then we are going to get a number in T which is greater than this number, and the meaning of this is that this m minus epsilon is not an upper bound. This m minus small m into minus epsilon is not an upper bound, and this m minus n is upper bound. That means any number less than that number, any number less than this number, which form, m minus m into minus epsilon form ना, उसमें से कुछ पॉजिटिव नंबर हम घटा रहे हैं, और हम कह रहे हैं अगर कुछ भी आपने घटा दिया ना तो वो अपर बाउंड नहीं रहेगा. That means what? m minus m must be
upper bound, lower, least upper bound.
least upper bound, supremum.
Yes.
Okay?
Yes, sir. Got it.
Yes. Okay. Now actually 3 questions are to be left. I am hoping तुम इसको try कर लेना, अभी time भी हो गया, ठीक है? और ना आए तो you can mail me, okay?
Yes, sir. We have other class also.
You have maybe another class.
Sir,
please try to solve this question. Yes.
Sir, can we mail you questions if we practice from other books? Suppose the ones which
you
sir
can
has
mail
told
me,
us to
okay?
refer.
Yes, it's good actually. If you practice the books, it's very good. You can mail me. I will try to reply your questions.
Sir, if we have doubt in
Okay.
these questions, can we discuss in another tutorial?
These questions 12, 13 and 14.
Yes, sir.
Yes, maybe if next tutorial have some less question, then definitely we may discuss this question.
Yes,
Okay.
sir. Thank you.
Okay.
सर मेरे से
Yes.
क्वेश्चन ही नहीं बन रहे ये सब, मतलब खाली एक दो ही क्वेश्चन हुए मेरे से.
तो मैंने इमेज डेफिनेशंस पे फोकस करो. मैं डेफिनेशंस के अलावा कुछ भी यूज नहीं किया. उनको फील करने की कोशिश करो. डेफिनेशंस को सर से कांटेक्ट करो. जो सर पढ़ा रहे हैं ना आपको, जो भी फैकल्टी, वो आपकी जरूर हेल्प करेंगे. आप उनको मेल करके क्वेश्चंस पूछिए एक बार कि सर मेरे से ये समझ में नहीं. आप कुछ भी नहीं का तो आंसर नहीं हो सकता. तुम्हें कुछ तो बताना पड़ेगा कि ये नहीं हो रहा. कुछ पार्टिकुलर चीज मेंशन करना सर को कि सर मुझे लिस्ट ऑफ बाउंड के क्वेश्चन नहीं हो रहे, या लिस्ट ऑफ बाउंड की डेफिनेशन नहीं समझ में आ रही, तभी तो हेल्प होगी ना. अगर कुछ भी नहीं हो रहा तो फिर सर कैसे सोचेंगे उसके बारे में.
सर नहीं, एक्चुअली सर
तो
ये जो पार्ट है
कॉन्ट्रडिक्शन वाला प्रॉब्लम आती है हम लोगों को.
इसमें
सर
आती है?
एक्चुअली
कॉन्ट्रडिक्शन से प्रूफ करने में, मतलब.
हाँ.
अच्छा, कॉन्ट्राडिक्शन का मीनिंग एक्चुअली क्या है कि कोई कहते कि इस क्लास के सारे बच्चे पास हैं, है ना, तो तुम मान लो कि सारे बच्चे पास हैं, और जब जाके आप एक एक से पूछो, आप फाइंड आउट कर लो कि रही ये बच्चा तो फेल है, तो इसका मतलब कॉन्ट्राडिक्शन मिल गई, तो इसका मतलब क्लास पास नहीं है. तो वही चीज है ना, कुछ मान लेते हैं कि वो जो चीज हमें चाहिए ना उसका अपोजिट मान लेते हैं, और फिर नीचे जाके देखते हैं कुछ ना कुछ मिस्टेक मिल जाती है, जो चीज होनी चाहिए वो नहीं हो रही. तो यही है बस जस्ट कॉन्ट्राडिक्शन, और कुछ नहीं है. मतलब कि कोई चीज अगर हमें प्रूफ करनी है, उसकी अपोजिट मान लो कि मान लो वो नहीं है, तो देखते हैं क्या सारी चीजें सही हो रही है क्या. अगर कुछ ना कुछ गड़बड़ मिली तो वो चीज गलत है तो हमने माननी है. अगर सारी चीजें, तभी तो मैंने आपको ये क्वेश्चन करने को बोला ना, √4 इज ए प्राइम नंबर और नॉट. ट्राई दैट कंट्राडिक्शन मेथड, देन यू रियलाइज. अगर आपने इसको भी रैशनल प्रूफ कर दिया ना, तो इसका मतलब आपको वो प्रूफ समझ में नहीं आया है, फिर आपने वो लाइनें ही लिखी हैं केवल. ठीक है. अगर किसी भी चीज को रियलाइज करना है ना कि ये प्रूफ सही है कि नहीं, उसकी एक आध कंडीशन हटा दो और फिर प्रूफ करने की कोशिश करो. अगर फिर भी आप प्रूफ कर देते हो ना, या तो वो प्रूफ ही कुछ गलत है, या फिर आप उसको सही से नहीं समझ पाए, क्योंकि जितनी भी कंडीशनें दी होती ना वो सारी यूज होनी चाहिए उस प्रूफ में. दिस इज द मेन एम.
यस सर.
तो इसीलिए √4, √5 और √6 इनको कंट्राडिक्शन मेथड से ट्राई करो. आपस में एक दूसरे की गलती पकड़ने की कोशिश करो, ग्रुप में डिस्कशन करो. फिर भी अगर ना हो तो मेरे को मेल करो, मेरे को टाइम मिलेगा, मैं देख के जरूर रिप्लाई करूंगा. ठीक है.
Excuse me, sir. Recording you will like post in the classroom itself, right?
What you are saying?
Sir, recording आप Google Classroom में डालोगे, right?
सर ही डाल देंगे. हाँ, ये रिकॉर्डिंग आपको मिल जाएगी क्लासरूम में, उसमें गूगल क्लासरूम.
Okay, sir. Okay. Thank you, sir.
Okay, thank you. You may leave now. Thank you very
Yes,
much.
sir.